Let's wait for 2 minutes. Let the rest of the people, they can also join.
अस्सलाम वालेकुम सर। सर वो आप कह रहे थे दूसरा ऐप मैं यूज करूंगा पर उस पे आए नहीं, ये उस ब्रेक आते हैं, वो स्टडी का मोशन जो है वो सारा खराब कर देते हैं 10 मिनट का।
वो असल में वहाँ पे रिकॉर्डिंग का मसला हो रहा है उसमें।
सर वो रिकॉर्डिंग का मसला हल हो गया ना, वो आप अगर अपना पर्सनल लिंक क्रिएट करें और क्लास में भेजे तो वो आप वहाँ के ओनर होंगे, वहाँ के जब ओनर होंगे तो आप कर सकते हैं रिकॉर्डिंग।
चलें नेक्स्ट टाइम वो भी
वो जितने घंटे।
ठीक है।
सही है, सही है।
Let's wait for a minute and then we will restart.
Okay, sir.
Excuse me, sir.
जी जी
सर ये लास्ट में जो कैलकुलेशन की थी वो मतलब अल्फा के रेशो के बाद वो ज़रा दोबारा समझाए, उसके
मैं आता हूँ,
समझ
खैर
नहीं आया सर।
मैं आ जाता हूँ, दोबारा करा देता हूँ।
ठीक है सर, ठीक है सर, थैंक यू सर।
Okay जी, so we said that if we take a look of the output characteristic curve, so here is what we are talking about. So we say, let's suppose if the input current is 0, this means that when IB is equal to 0. And how IB can be equal to 0? If we go into the circuit, if we go into this circuit, which is the common emitter configuration, so how IB can be equal to 0? That when the VBB, the biasing potential at the base of the transistor is equal to 0. So this means that the base emitter junction is not forward bias, right? When the base emitter junction is not forward bias, so this means there is no current which is flowing in the base of the transistor. So when this is the situation, so we have the transistor that is looking something like this, that there will be a current which is flowing through the collector emitter junction. The current which is flowing through the collector emitter junction, and we call this thing ICEO. ICEO represents the current which is flowing through collector to emitter junction when the base is open, means this current is being called as ICEO, right? Okay, so last time in the common base configuration, we obtained this equation, which is IC is equal to alpha times IE plus ICBO. Now we also know this thing that IE is equal to IC plus IB, where IE is the emitter current, IC is the current which is flowing in the collector circuit, and IB is the current which is flowing in the base circuit, right? Now replacing IE with its equivalent value in the equation above. So what we are going to get? We are going to get this, which is IC is equal to alpha times IC plus IB plus ICBO, or we can say IC minus alpha times IC is equal to alpha times IB plus ICBO, and then doing the mathematical simplifying the equation. So what we are going to get, IC is equal to alpha divided by 1 minus alpha IB plus ICBO divided by 1 minus alpha. Now as we know sorry, as we know, the base current in our case is, we are taking IB is equal to 0. So we get the equation IC is equal to ICBO divided by 1 minus alpha, right? Because we say that the base current is equal to 0. And normally the value of alpha is in between 0.9 to 0.998, which we can, the maximum which we can take as the value approximately equal to 1. Why? Because alpha is approximately equal to IC by IE, or because when we say IC is equal to approximately equal to IE, so we say alpha is equal to approximately equal to 1. But the practical value of alpha is, we take our here, which is 0.996. So if we place the value of alpha as 0.996, so what we are going to get, that it will be equal to ICBO divided by 0.004. Are you with me up till now?
Yes, sir.
Yes, sir.
Okay, so if we replace IC with its equivalent value, which we started with, IC is equal to ICEO. Why? Because we replaced the collector current with its equivalent, which we said it is going to be represented as ICEO. ICEO is that current which is flowing through collector to emitter junction when the base is open, right? So ICEO is equal to ICBO divided by 0.004. And when you do the calculation, this becomes equal to 250 times ICBO, right? So when we go back to our characteristic curve over here, so what we see, that when the base current is equal to 0, the current which is flowing over here is ICEO, right? And ICEO is actually having a magnitude which is 250 times the magnitude of ICBO, right? So due to that, this current is not almost going to be 0, but this current is going to be something bigger than ICBO, right? So what we say, it is normally something bigger than ICBO. So it is just above the uh, horizontal axis, which is being represented as the current IC, right? So it is going to be something visible on the scale of milliamperes, because if you see, it will be something very close to, or it will be something of the size of, in, you can see it on the scale of milliamperes, because it is 250 times the value of ICBO, right? So it will be something greater than which we have seen in the common base configuration, right? So now this is basically the value which we are going to see. Now let's suppose if we increase the value of IB, if we say IB is equal to 10 microamperes. Let me just rewrite. So if I say over here, and IB was equal to 0. Now if I say IB is equal to 10 microamperes, right? So if IB is equal to 10 microamperes, so normally the value over here, it is going to have the corresponding value in the collector circuit due to this. Why? Because if you see, we have another ratio over here. And other ratio over here is normally called as beta.
सर स्क्रीन हैंग छे हुए सर
नखकारी?
नो ये सर वो रुका हुआ है IB is equal to 10 माइक्रोएम्पेयर के बाद कुछ दिखाई नहीं दे रहा
अच्छा एक मिनट अब कुछ हो रहा है
नहीं सर सर
मूव
एक
हो
बार
रही
स्क्रीन शेयर बंद कर दे
सर थोड़ा
हाँ,
सर
मूव हो रही
मूव
है
हो गया
ओके ओके ओके
मूव हो गया
ओके वो फॉर द टाइम बीइंग वो नेट में मेरे हाथ में कोई थोड़ा सा लैग आया होगा ओके so what is happening that as we know that when the base current is now flowing, right? So this means that the base emitter junction is now forward bias, right? When the base emitter junction is forward bias, and we also know this that over here we are going back to the circuit, and what we say that we make the biasing potential variable VBB as well as we make this VCC variable, right? Are you with me? So when we make VBB increase, so this means IB will also increase over here. And now let's suppose IB becomes 10 microampere over here, right? When IB becomes 10 microamperes over here, so due to that, the corresponding value, due to there is a factor over here, is called another factor over here, it is called beta. Now beta is basically the ratio of IC to IB. Right? And normally the value of beta is varying in between 50 to 250. Right? So if we say beta value is 100 over here, and IB is, in our case, is 10 microamperes, right? So the value of IC from this we can deduce it is going to be something 100 into 10 microampere. So this will be, it will be something 1 milliampere. Are you with me?
Yes, sir.
Right? So this means when IB is something 10 microamperes, the range of IC will be somewhere in 1 milliampere, right? So if we go back to the output characteristic curve, and what we see that if IB is in the range of 10 microamperes, we can have IC as 1 milliampere, right? So normally if we are changing the value, so this value will be something close to 1 milliamperes approximately. Are you with me? Question? Is this thing fine? Are you with me?
सर
Yes,
आपके
sir.
साथ है पर समझ नहीं आ रही
Yes, sir.
अजीब सा है सर
Acha. Okay. Let me go back again, right?
Sir,
So let's see it again.
yes.
So what we are talking about, if you see, okay, this thing is clear. When IB is equal to 0, we have the value which is something ICEO, right? Is this thing clear? When IB,
yes sir
when IB is equal to
No, sir.
जी,
सर ये भी पूरा क्लियर नहीं है सर.
ये दोबारा से कराऊं?
Yes, sir.
अच्छा जी, दोबारा से देखें, चलें. Okay, what we have said initially, coming back, if the base current is 0, right? So if the base current is 0, this means that there is no forward biasing of the base emitter junction, right? When the base emitter junction is not forward biased, so this means there is no current which is flowing in the base of the circuit, right? And that condition will be taken as in the transistor as ICEO. ICEO means that it is that collector current which is passing through collector emitter junction when the base is open, right? And with this one, we had obtained this equation from the common base configuration circuit, which we have done last time. IC is equal to alpha times IE plus ICBO. We also know this thing that IE is equal to IC plus IB, right? So putting this value in the equation over here, IC is equal to alpha times IC plus IB plus ICBO, right? And if you do the mathematical manipulation, so by doing that, we are going to obtain IC is equal to alpha divided by 1 minus alpha into IB plus ICBO divided by 1 minus alpha. Now, in our case, when we say IB is equal to 0, so this means alpha divided by 1 minus alpha into IB, this whole term, when we put IB is equal to 0, so this whole term will be 0, right? When this whole term will be 0, so we are left with this IC is equal to ICBO 1 divided by 1 minus alpha, right? Are you with me?
Yes, sir.
And normally the value of alpha,
yes
normal value of alpha is in between 0.9 to 0.998, because what we say that IC is almost equal to IE, so we can say approximately this is equal to 1. And the practical value of this can be, because it is the range from 0.9 to 0.998. So we take the one of the practical value from here, which is we inserted for alpha. So it is ICBO divided by 1 minus 0.996, and 0.996, if you do the manipulation, this will be equal to 250 times ICBO. But this IC value is now being called as ICEO, because it is that current which is flowing in the collector emitter junction when the base is open, right? ICEO. It is that current which is flowing in collector to emitter junction when the base
د غشیره وړه لکه باران دی.
when the base is open, right?
सर ये अल्फा की ये वैल्यूज कहाँ से आई है सर?
ओके, अल्फा की ये हमने ना डेटा शीट से ली हैं जो प्रैक्टिकल वैल्यू हैं, राइट? तो ये जब आप कोई भी ट्रांजिस्टर खरीदते हैं तो ये उसकी वैल्यू होती है विच कैन वेरी इन बिटवीन 0.9 टू 0.998, राइट? सो हमने उससे एक प्रैक्टिकल वैल्यू लेके हमने यहाँ पे इंसर्ट कर दी है, और उससे हमने एक एस्टिमेट लगाया है कि ICEO वैल्यू जो है दैट विल बी इक्वल टू 250 टाइम्स the ICBO value, right? So therefore when we are drawing it on the output characteristic curve over here, so if you see, it is not at the very base, but it is just above the base, right? Because it is something bigger in size than compared to the ICBO value. So therefore this is more prominent than the ICBO value. ICEO is that current which is flowing from collector to emitter junction when the base is open, right? Now what we do, we, coming back to the circuit, what we do, we increase the value of the base biasing voltage, right? VBB. So when we increase this VBB, so what happens that the current in the base will increase. And let's suppose now the current in the base is equal to 10 microamperes, right? When this is going to be 10 microamperes, so we have another ratio in between the collector and the base currents. IC divided by IB is normally called the beta, right? And the beta practical value is in between 50 to 250. So we take one of the practical value, which is 100. So if we take 100, this means the IB is equal to 10 microamperes. So IC will be equal to 100 into 10 microamperes. IC will be equal to 1 milliampere. Are you with me?
सर ये जब सर्किट सर रिवर्स बियास्ड है तो सर तो वोल्टेज इंक्रीज से फिर आईबी करंट क्यों इंक्रीज हो रहा है सर?
सर्किट कहाँ पे रिवर्स बायस है?
सर आपने कहा ये हम आउटपुट के लिए ये जो कर रहे हैं ना ये सारे इक्वेशन वगैरह, तो सर ये तो रिवर्स बियास्ड है ना, वो क्या है इनपुट सर्किट के लिए, तो बेस तो इनपुट में आ रहा है ना सर।
रिवर्स बायस क्या है ये बताएं चलें।
सर रिवर्स बायस वो है सर जब बेस को हम वो नेगेटिव के साथ कनेक्ट कर लेना सर।
बेस को हमने किसके साथ कनेक्ट किया हुआ है जरा देखें आप इस सर्किट।
सर यहाँ पर तो पॉजिटिव के साथ है, लेकिन अभी सर हम तो जो इक्वेशन निकाल रहे हैं वो तो सर हम एमिटर के लिए निकाल रहे हैं ना, तो सर आपने वहाँ पर IB 0 लिया हुआ है ना।
तो अब तो मैं कह रहा हूँ IB हमने इंक्रीज कर दिया ना, IB अभी हमने इंक्रीज नहीं किया। VBB से हमने जब VBB की वैल्यू इंक्रीज की है तो उसकी वजह से बेस इमिटर जंक्शन फॉरवर्ड बायस हो गया है। जब वो फॉरवर्ड बायस हो गया है तो उसकी वजह से IB जो है हम कह रहे हैं 10 माइक्रो एम्पियर्स करंट फ्लो कर रहा है।
ठीक है
ठीक है जी। सो जब ये कंडीशन हो गई तो फिर हमने IC की वैल्यू भी फाइंड करनी है कि व्हाट इज द वैल्यू ऑफ IC। सो फॉर दैट व्हाट we have this thing which is called beta. Beta is basically the ratio in between IC and IB. Normally the value of beta which is in between the range of 50 to 250. So we take one of the practical value from here, which is beta is, let's suppose, 100. So to have a simple calculation, this means IC will be equal to 1 milliampere over here, right? Are you with me now?
Yes sir.
sir.
So coming back to the output characteristic curve over here. So what we have, when IB is equal to 10 microamperes, so IC will be in the range of something 1 milliampere. Are you with me now?
Yes sir.
Yes sir.
And similarly, what we do, we increase the value of VBB over here. When we increase the value of VBB over here, so what happens that now previously we said IB was 10 microamperes, so now it will be, let's suppose we increased it and we make it, let's suppose we make it 20 microamperes, right? So by making it 20 microamperes, so correspondingly the value of IC over here will become 2 milliamperes.
2 milliampere.
ठीक है जी. So when this become 2 milliamperes, so this means we will have something value which is close to 2 milliamperes when IB is equal to 20. IB is equal to 20 microamperes. Are you with me?
Yes sir.
Yes sir.
Similarly, if I increase the value of VBB further on, so I say the value of IB becomes, let's suppose, 30 microamperes. So correspondingly, the value of IC is 3 milliamperes, and we have something like this. Are you with me?
Yes sir.
Now,
Yes
is this thing clear up till now?
Yes
sir.
sir.
Yes sir.
Yes sir.
जी फादुल्ला सोए तो लास्ट उचत खड़े रहे.
सर हम इस सर्किट में VCC को वेरी नहीं करते.
अभी आ रहा हूं ना, अभी करते हैं ना.
यस सर. ठीक है सर.
ठीक है जी. सो अब आप देखें. So as you can see, if we go back to the circuit now, if you go back to the circuit, what we have shown that VCC is variable, right? So this means when you are having variable VCC, so this means you can change the value of VCC, and when you change the value of VCC, this means eventually you will be able to change the value of VCE, right? VCE is basically the potential from collector to emitter junction, right? So if you are varying this collector to emitter junction voltage, so what is happening over here, that if let's suppose you are reducing this value and we are over here at IB is equal to 30 microamperes, and this means correspondingly we have the IC is 3 milliamperes, right? Now when you are reducing the value of VCC, this means you are reducing the value of VCE eventually, right? Now, if you see we are reducing, so this means the curve is somewhere over in this range. We are somewhere here, right? Now, if you go beyond this, what happens? If you try to reduce the value from this point, this means you are reducing the value somewhere here. Are you with me?
Sir, screen hang the.
Nakari?
Hang the hang.
कारी सर
Kari? जो स्क्रीन
हाँ
खोजो पता लगी?
उस
यस सर
साइड
हाँ
लगी.
मोशन की
हाँ
Yes,
जबरदस्त
यस
sir.
सर
केदी नेट के कला कला लैग राशि के देव जा स्क्रीन के तास्ता हैंग कारी. Okay,
Yes.
so what I'm saying that we are reducing the value of VCC, the biasing voltage, right? And we are at this where IB is equal to 30 microamperes. So this means IC is somewhere close to 3 milliamperes. Now, if I'm trying to reduce the value further on from this line, which I have drawn, the line which I have drawn over here, right? You can see this line now. So
yes sir, yes sir,
if I
नजर
am
आ रहा है.
trying to reduce the value of VCE further on from here, what happens that the current starts to decrease. Now let's get back to the circuit over here. In the circuit, if you see what we have, that the potential, if I say VCC is equal to 0, if I say VCC is equal to 0, what does this mean? If I say VCC is equal to 0, if VCC is equal to 0, so what does this mean?
IC is equal to 0.
This means that the potential at the collector at this specific point and the potential at emitter is same. Are you with me?
Yes sir, yes sir, VCE is equal to 0.
नो सर सर रिपीट करे सर ये आवाज में थोड़ी ग्लिच आ रही.
Okay, if I say VCC is equal to 0, right? So this means VCE is also equal to 0,
Yes sir,
right? When VCE is also equal to 0, so what we say that the potential in between base to emitter is 0.7 volts, right?
yes sir,
Are you with me?
yes sir,
So when the potential between the base to emitter is 0.7 volts, so this means the potential between base and collector is also 0.7 volts.
yes sir,
Yes, sir.
Are you getting this point?
Yes, sir.
yes sir,
This means when VCE and VCB over here is basically what it is indicating that the potential over here is making the collector base junction no more reverse bias, right? Are you with me?
yes sir,
Now to make the collector base junction reverse bias, the potential at the collector needs to be 0.7 volts above than the base,
Yes, sir.
right? Because if this potential is not more positive than the base, it won't make the collector base junction reverse bias. Are you with me?
Yes, sir.
Right? So this means that if I go back to this circuit over here, so if you see, this is 0.7 volts over here, right? So if I go beyond this, so this is no more reverse bias, that the collector base junction is no more reverse bias, and therefore the collector base junction becomes forward bias if I go from here onward, right? And if I start reducing from here, this means we are going into the saturation region, because from this point onward, the collector base junction and the emitter base junction both are forward bias. Are you with me?
Yes, sir.
Yes, sir.
ठीक है जी? So this is basically the saturation region in which both the emitter base and the base emitter junction, or we can say the base collector junction or collector base junction, are forward
Forward
bias,
bias.
right? So this is our
Yes, sir.
saturation region. Now this is our active region
Active. Yes,
or
sir.
linear region. Active or linear region in which the emitter base junction is forward bias and the collector base junction is reverse bias,
Reverse bias.
right? And this region over here at the bottom, this region over
Off
here
region.
at the bottom, this is basically called
Off
the
region.
cut off region, in which the emitter base junction and the collector base junction both are reverse
Reverse
bias,
biased.
right?
Yes.
ठीक है जी? So
Yes, sir.
this is basically the circuit which we are dealing with, right? So we have the active region, we have the saturation region, and we have the cutoff region. Okay, if we come towards the basic equation over here, what we have seen up till now, that we have IC by IE is equal to alpha, and we have IC divided by IB equal to beta, right? Where alpha is the current